right, good morning. No, that's 2 days in a row. Good afternoon. I don't know what time it is. Time doesn't exist anymore, man. There's just the quarantine. There is no time. Okay, so last time we talked about infinite geometric series. So we had talked about what a geometric sequence was. We talked about how to find the partial sum. We had a formula for that. And then yesterday we talked about an infinite geometric series and how it could be possible to find the sum of an infinite series. All right? Because we said infinite series can either diverge or converge. All right, but since this specifically says infinite sum, so I'm imagining, what if I added up all the terms of this sequence? Well, not all. We never stopped adding up the terms, right? We plug in 1, we plug in 2, we plug in 3, we plug in 4, we add all that stuff up forever. Will we get something? I don't know. Let's find out. So, remember the kind of explicit form of a sequence for a geometric series is, it looks like this. And so I can tell this looks like it has all those pieces, right? Like an A1, an R, and then to the n-1 power. So this is in the form of a geometric sequence, which tells me if I want to know if its infinite sum will converge or diverge, I just need to look at R, right? So the ratio here is pi over 3. Okay, so we want to take a look at pi over 3, and we want to compare it to 1. So will the absolute value of pi over 3 be greater than 1 or less than 1? Well, it's greater than 1, which means this infinite series diverges. Right, and diverges means there is no sum. Right, that means if I add up all those terms, I'll end up at either positive infinity or negative infinity. So, diverges. If we had got something that was less than 1, then we would use our formula of A1 over 1 minus R. That's if it converges. Okay, but it doesn't, so we couldn't use this formula. Instead, we just have to say it diverges, and that's that. We're done there. Right, there is no sum. Okay, so today we're gonna focus on talking about Pascal's triangle. Our topic for today is binomial expansion. And so one thing that can help us, so binomial expansion means like, what happens if I have x plus y squared? Well, we know through foiling you would get x squared plus 2xy plus y squared, right? But what about if I don't have squared? What if I had x plus y cubed, or to the 4th, or to the 5th power, or to the 6th power? And if I didn't want to sit there and do all that multiplication out by hand, is there a better way to know if I multiplied all this stuff out what I would get? And there definitely is a better way. So one of those ways is by looking at what's called Pascal's triangle. Wonderful guy named Pascal came up with this great triangle. So as you can see, it's built with 1s around the outside, but here's how this works. So you start with just 1 at the top. Right, for these top 3 values, it's just, they're 1s, right? 1, 1, 1. Then, to get the values for the next row, we do some addition. Right, so 1 plus 1 is 2. Okay, and then the outsides is always going to stay 1. That's just like a rule, right? We can see 1s are all along the outside, 1s are all along the outside. All right, we go to the next row. Well, 1 plus 2 makes 3. 2 plus 1 makes 3, but 1's on the outside. And then to the next row, 1 plus 3 makes 4. 3 plus 3 makes 6. 3 plus 1 is 4, and then 1's on the outside, etc., etc. 1 plus 4, 5. 4 plus 6, 10. 6 plus 4, 10. 4 plus 1, 5. And it just continues on. Right? And we could keep going forever. We can make this as large as we want. Right? This is called Pascal's triangle. And this pattern is just that in order to get the number for the next row, you just add the 2 numbers that are above it. Okay? Now that's kind of a neat little pattern, right? Great. And the interesting thing about this is this will very much help us make a binomial expansion. All right, so let me show you what I mean. So how can we use Pascal's triangle to expand binomials? The numbers in Pascal's triangle are the coefficients of the expanded binomials. All right, we call the top row row 0, and the row number corresponds to the exponent of the binomial we want to expand. Okay, so that's a lot of information that probably doesn't make a ton of sense. So let me move this over. Okay, so this is just showing exactly kind of what that said. So this first row is row 0. Second row, I know we call it, when n equals 1, or n equals 2, or n equals 3, etc. Okay, this is the row for n equals 4. This is the row for n equals 5. This is the row for n equals 6, etc., etc., etc. You didn't get the notes? Did I not send them? I'll resend. I'll try to resend. Let's see. Math analysis. 4/29. Wednesday. Attach. Okay, I just tried it again. Let me know if that works. Wow. Dude, it is really windy outside. Are you guys feeling this? Or hearing? Holy crap. That was crazy. I was trying to look up the wind. Maybe not the right time for it. Okay. Let's go back to math, I guess. I can't get over that. All right. So let me show you how this works. Let's just use it in practice. It's much easier to tell. So expand the binomial. X plus y cubed. So here's the pattern. If this is my exponent, if my exponent is 3, then that means n equals 3. So I'm going to go to my n equals 3 line, and I see that my coefficients are 1, 3, 3, 1. Okay? So I'm just going to go ahead and actually put these. I'm going to put a 1, 3, 3, 1. Kind of space them out like that because I'm going to need to fill in. And now I'm going to look at this x and y. So every term is going to have an x on it. X, 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 x. Every term is going to have a y on it. Y, 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 y. Okay? And now here's what we do. So we kind of start almost opposite. So for the x, this first term in whatever the binomial is, I'm going to make that exponent 3, right, which is just whatever the n is. And then for each next term, I'm just going to go down 1. So x cubed in the first term, x squared in the first term, or sorry, in the second term, x to the first in the third term, and x to the 0 in the last term. Okay, so we can see it just, the exponent just goes 3, 2, 1, 0. Right, and the other term is going to go backwards, basically. So instead of starting at 3 and ending down at 0, the other term is going to end at 0 and then go up 1 to 1, and then go up to 2, and then go up to 3. And lastly, these are just all added together. Plus, 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 plus. All right. So now let's just do a little bit of simplifying. Y to the 0th power is 1. This is just 1. So really that first term is just x cubed. I don't need to write times 1 and times 1. This term, so 3x squared, y to the first I can just write as y. 3x to the first, y squared. X to the first I can just write as x, so 3x y squared. Plus 1 times x to the 0. X to the 0 is just 1. So 1 times y cubed. So plus y cubed. All right, so there's my answer. So again, the kind of key part of this is we could just kind of use some patterns. We don't even really need to do any math, right? Just the 1, 3, 3, 1 came from this third row of Pascal's triangle, 1, 3, 3, 1. And then we just put the other stuff in there and then had this pattern of the exponent. So started at 3 and then went down to 0. And then the second exponent started at 0 and then went up to 3. All right, so pretty interesting. Now, maybe not super necessary for just cubed. It's possible some of you already have the formula memorized for x plus y cubed. Maybe. I think it's something that's talked about like in Algebra 1b maybe, or Algebra 2. But this is especially helpful if we start getting into larger exponents. And I don't want to sit there memorizing formulas for 4th power or the 5th power or 6th power. You know, FOIL is good enough to use for squared, but other than that, I really don't want to sit there and memorize a formula for each exponent. But can I just use Pascal's triangle to make stuff? All right, that's the hope. So let's do this. 3a minus 1 to the 5th, and I want to expand this binomial. All right, first thing I'm going to look at, n is 5. Okay, so I'm going to go to the 5th row, n equals 5, or not the 5th row, technically the 6th row, right? Because this first row is 0, is if n is 0. So n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. So that's 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. I'm just going to jot those down. 1, 5, 10, 10, 5, 1. Okay, and I'm just going to use these. Finley, did you get those notes, by the way? Or did any of you guys get those notes, by the way, that I just tried to send again? Maybe my email is not, maybe it's busted, I don't know. You got them. Did you get them at first, or did you get them just now? Just now. That's weird. I don't know. Maybe I screwed something up when I sent it before. It says I sent it. I don't know. Okay. All right, so we're just going to use each of these coefficients to build each term. All right, so this first coefficient is 1. All right. My first term is 3a. I'll put that in parentheses. All right, remember, and the first term starts with at the highest exponent. So this one starts at 5, so 3a to the 5th. And then the second part, negative 1, so negative 1, remember that starts at the opposite. That starts at 0. Okay, so this is my first term. Now let's go to the second term we made using this 5. So plus 5, and then 3a, but we go down 1, so from the 5th power to the 4th power, and then the negative 1, but instead of the 0th power we go up 1 to the 1st power. All right, so now I move on to using the 10, so plus 10, 3a goes down to cubed, negative 1 goes up to squared. And now we have 10 again. (3a squared) negative 1 cubed back to 5. (3a to the first) negative 1 to the 4th. Let me shift this over a little bit just so I don't run out of space. And then this last one, so plus 1 times 3a to the 0th times negative 1 to the 5th. Guess I should move this over as well. I'm still bad about forgetting whenever something is behind my head. Okay, so 1, 5, 10, 10, 5, 1. That's those coefficients right here. 1, 5, 10, 10, 5, 1. All right, and then as for the rest of the term, it's just built out of each, the first term of the binomial, the second term of the binomial. But whatever the first term is, start that off at the highest exponent. So in this case, 5, because n equals 5. The second part of the term started at 0. Right? That second part goes up 1 each time, from 0 to 1 to 2 to 3 to 4 to 5. The first term's exponent starts at the top and then goes down, 5 to 4 to 3 to 2 to 1 to 0. And then now let's actually just do some simplifying. So 1 is 1. Negative 1 to the 0th power is also 1. So really it's just 3a to the 5th. So let's see. What is 3 to the 5th? 243. I should have known that. So first term is 243, a to the 5th. We have negative 1 to the 1st power here. So I know that this term is going to be negative. We have a 5. We have 3 to the 4th. So 3 to the 4th is 81. So 81 times 5 is 405. A to the 4th. Okay, plus -1 squared, so that will become positive. 3 cubed is 27. 27 times 10 is 270, so 270a cubed. Again, I have now a -1 to an odd power, so I know this term's going to be negative. 3 squared is 9. 9 times 10 is 90, so minus 90a squared. -1 to the 4th, even power, so that will be a positive, so this will be a positive term. 3 to the 1st is 3. 3 times 5 is 15, so plus 15a. Plus 3a to the 0th power is 1 times 1. -1 to the 5th power, so that will stay negative, so my last term is just -1. Okay, so there's my simplified expanded binomial. So very useful, very, very useful. Okay, hopefully this makes sense. Hopefully I'm trying to color code it best that I can here, which I think, well, I don't know, to me makes sense, obviously, but I'm the teacher. But start with the coefficients. From there, we just use each of these terms in every term of the expanded binomial, but there's just the pattern of the exponent, either starting at the top and going down, or starting at the bottom and going up. All right, and after that, it's just simplifying. All right, next up. Expand the binomial, 4x minus 3 to the 4th power. Okay. So since it's to the 4th power, so n equals 4. So I'm going to go to n equals 4, that row. Again, be careful. Make sure you know that this top one is technically when n equals 0. Right, which makes sense because anything to the 0th power is just 1. Right? There won't be any binomial because it's just to the 0th power. Right, 1 squared cubed to the 4th power. So 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. I'm going to write that down again. 1, 4, 6, 4, 1. And I even remembered to write it not behind my head. So this is pretty insane. I'm such a good teacher. Right? At least that's what the chat's saying. So expand the binomial. Let's just start with the first coefficient, 1. All right, we'll say 4x is our first piece. So 4x, and that starts with the highest exponent, which in this case is 4, n equals 4. And then we'll say -3 is our second term, and that starts at the lowest exponent, which is 0. Right, first term. Now move on to the second term, so that'll be plus 4. 4x, it goes down to cubed. -3 goes up to the first power. Right, next term, we use the 6. 4x squared. -3 also squared. Plus 4. (4x to the first). -3 cubed, and then plus 1, 4x to the 0th power times negative 3 to the 4th power. The longest part of these types of problems would probably just be the simplification. All right, because if you can get good at, copying the coefficients is just looking at the Pascal's triangle row, copying those coefficients over, and then it's just doing the pattern, right? 4, 3, 2, 1, 0, 0, 1, 2, 3, 4, right? So writing out this part should be quick if you know what you're doing. Then it's just a matter of doing the simplification, which even then shouldn't be too long. It might be more annoying, that's for sure. All right, negative 3 cubed, negative 3 to the 0th is just 1, so 1 times 1. So all we have is 4x to the 4th. So the 4x, what is 4 to the 4th? 256, right? Yeah. Yeah, 256. Okay. Had to punch that in to make sure. 256 x to the 4th. Again, negative 3 to the 1st power. There's no other negatives here, so that will just make this negative. 3 times 4 is 12. 12 times 4 cubed. 12 times 4 cubed. 768. X cubed. Negative 3 is being squared, so that will make this positive. So positive 9. 9 times 6 is 54. Times 4 squared, so 54 times 16. 864x squared. Next term, negative 3 to an odd power, so that will be negative. Negative 3 cubed would be negative 27. So 27 times 4, right? This first 4. Oops. 27 times 4 is 108. And then 108 times 4 again, 432. Plus negative 3 to the 4th. So yeah, that'll be plus. That's 81. 81 times 1 is 81. This is just 1 again, so this last term is just plus 81.